Hello there, class. All right, today's a little more involved than we have been. We're going to talk about sleep cycles or stages of sleep. So this is day 3 of Advanced Health Psychology B. Your essential question today, the title, of course, is Day 3 Sleep Cycles. Your essential question today is, how does NREM differ from REM? And usually psychology professors seem to call it NREM and REM. Main ideas: sleep cycle. Subtopics are REM and NREM. And today I would like you to actually set up a mind map no matter what you do, because then it'll be easier to follow me. And I would like you to set it up in the way that I've shown. So if you scroll down, you'll see sleep cycles, NREM on top, with 4 lines coming off of that. Those lines are numbered, and then 4 lines coming off of REM. There's also a box and it says wave patterns. Go ahead and copy that now. Pause. All right, we're back. First thing I want to do is talk about wave patterns, because it's necessary to know a few terms before we get into the brainwave activity that we see during sleep. If you scroll down below output, you will see the wave pattern diagram. You will see that wavelength goes from, there's a line that runs through the center of the wave pattern, and that's called the resting position. So that would be if nothing's happening. We see a wave begin at the resting position, and then it goes up to a peak, down to a trough, and back to the resting position. Wavelength is the length between the first resting position and the third hit, the second hit on the resting position. A wave pattern is a repeating pattern, so up, down, rest. That would be the wavelength. Wavelength is also measured from peak to peak. You can go peak, peak, and then this becomes the wavelength. When people say wavelength, that's what they mean. Amplitude is how far from the resting position the peak is. A high amplitude wave would be this. A low amplitude wave would be this, because low amplitude means it's less far from the resting position. Frequency is how many cycles you see per second. So up, down, back to rest is 1 cycle. A high frequency wave pattern would be this. A low frequency wave pattern would be this. That is what is meant by amplitude and frequency. And I threw in wavelength there because you need to know what wavelength is. So you can see below the diagram that I have defined the terms. Frequency is how many cycles per second. And what we're going to find is that wakefulness features high frequency, low amplitude waves, meaning there are a lot of cycles per second, and the peaks and the troughs aren't very far from the resting position. High frequency, low amplitude would look like this. As we move into NREM sleep, we get alpha and theta waves. Alpha waves are lower frequency, higher amplitude. So instead of this, you're going to see more of this. Something like that. Theta waves are even lower frequency, higher amplitude. Like that. And delta waves, when you hit deep, deep sleep, are very low frequency, very high amplitude. So delta waves look like this. I'm going to say that a couple more times. Repetition is important in learning, so that's why I'm going to do that. We have now taken our wave pattern notes. You know what wave patterns are. Let's begin with non-REM sleep. So wakeful state is high frequency, low amplitude brainwave patterns. It goes like this. All right. When you move into the first stage of non-REM sleep, they call this the transition. I would like you to take notes on all of this. So go to stage 1 on NREM and call that transition. Here are the bodily changes that you experience during the transition to sleep. Respiration, breathing, and heart rate slow. your muscles relax, and your body temperature drops. You might have experienced this, especially if you're out camping on a cold night. When you sit down, you start getting sleepy, you also start getting cold. It's maybe more noticeable out there. We have uh, heating today and air conditioning, so we're shielded from that. But you'll notice that you maybe want a blanket. That's when you start snuggling up. And the wave pattern here is characterized by alpha and theta waves, and those are lower frequency, higher amplitude waves than the wakeful state. Alpha waves are lower frequency, higher amplitude. Theta waves are even lower frequency, even higher amplitude. We go from this to this to this. Something like that. Move on to NREM stage 2. Your body enters a state of deep relaxation. In stage 1, people might not even think they're asleep. If they're starting to fall asleep, we call it drifting off. See someone kind of do this, and you say, "Hey, you're asleep." They'll go, "No, I'm not." My wife does that all the time. So your body in stage 2 NREM sleep enters a state of deep relaxation, and you get theta waves with something called high frequency sleep spindles. So I want you to record that as notes too. So you have theta waves, which are lower frequency, higher amplitude, but then you'll get these sleep spindles, and then it'll go back to theta waves. So you get these bursts of activity, and that is thought to be important for memory and learning. Sleep spindles seem to be important for memory and learning. But even now, sleep is still largely a black box. There are advanced theorists who think they know how it works, but they haven't proven it, so we're going to leave it there. Stages 3 and 4 of NREM are related, and when you get to advanced psychology, we'll talk about the difference between stages 3 and 4. But what we need to know about stages 3 or 4, as far as body changes, are that heart rate and respiration slow even more, and that it's characterized by low frequency, high amplitude delta waves. So delta waves look like this. This is really, you're in a deep, deep sleep, right? Deep, deep sleep. Delta waves. You can write the same stuff for stages 3 and 4. I wrote 2 lines pointing to this. I just want you to know that there are 4 stages in sleep. I think there used to be 3, but they separated out 3 into 2 different stages. So for both of them, heart rate and respiration slow even more, and you get low frequency, high amplitude delta waves. This is all on figure 4.9, by the way, in your notes. You can look at that and see what I'm talking about. Now, after you go through stage 4, you enter the REM cycle. And we have 4 arrows coming off of the REM cycle. The first arrow, I want you to write rapid eye movement. This is because when researchers were first studying sleep, they noticed that people would cycle into periods where their eyes would move rapidly. You can look up rapid eye movement sleep on YouTube if you want to, and I've said this before, you can watch adults do it. I find it really creepy. There are a lot of videos where people who sleep with their eyes open, someone else filmed them for a psychology class, and you see their eyes darting around. I think it's a lot more tolerable in dogs and babies. I would look up REM sleep in dogs or babies if you're curious. It's kind of interesting. So this rapid eye movement sleep most resembles the wakeful state. Look at figure 4.9 and you will see that you get higher frequency, lower amplitude brainwave patterns in REM sleep. REM sleep doesn't last that long. It is also when dreams occur. So coming off of brainwave similar to wakeful state, I want you to write dreams occur. Now that's, in other textbooks, what I've read is that if a person wakes up right after a REM cycle, that they will say, "Hey, I had a dream and this is what happened." A person who is woken up out of REM may very well say, "I don't know, there were oranges." It's like a dream without a plot. So there's brain activity during NREM, but in REM you get dreams with a plot, like a story happens. It seems to happen just in REM sleep, at least as far as we know now. So we have 2 things coming off of REM so far: rapid eye movement and brain waves similar to wakeful state, and then coming off of that, dreams occur. The third thing, sleep paralysis. Your body paralyzes your muscles except for your circulatory and respiratory systems. So your body doesn't want you moving around at all during REM. And one thing I read thought that this might be adaptive, because if you're having a dream with a plot where you're maybe fighting a monster or something like that, what if you actually started fighting a monster? You could cause real problems and damage yourself. So the body paralyzes you during sleep. Sometimes people wake up in a REM cycle before the sleep paralysis subsides, and that's they'll wake up and they feel locked in, and then sleep paralysis subsides, and then they can move again. That's kind of fun to YouTube as well. Finally, the fourth thing coming off of REM. REM seems to be very important in memory and learning and emotional regulation. Well, how do they know that? People who don't hit REM don't learn as well, and they get really cranky. So they know it by the absence of good behavior, and they know it by the absence of memory, I guess. But again, all of this, your book is very careful to say seems. Sleep is still largely foreign country to us as far as science goes. At least mainstream science. There, again, you can read theorists and look up YouTube videos, and there are people who tell you what they think is going on, but it hasn't been proven with scientific method yet, at least not to the level that it's filtered down to a textbook. For today's output activity, I want you to actually hand copy, don't print it out and paste it, hand copy figure 4.9, and I've included that figure in your notes, and I want you to see that at wakeful state, you have very high frequency, very low amplitude waves, right? Stage 1 NREM alpha waves starts to do this. Stage 2 NREM theta waves, even more. And the theta waves include sleep spindle, right? So you're going along with your theta waves and go sleep spindle, like that. Stage 3 and 4, it turns to delta waves, like this, right? And then REM, you get high frequency, low amplitude waves again. Not as much as a wakeful state. Notice that it's not as active as a wakeful state, but it most resembles a wakeful state. And that's where dreams occur. And that's what I wanted you to do today. Thank you very much for your attention. I hope you continue to be healthy and safe with your family, and I hope you're not getting cabin fever too much. Bye-bye.